works? Well, the final one from this batch from the dealer in Sheffield is Fidelity 2000, so that's Cybernet 134. You get the bigger speaker on this, which makes it better than a Rotel 230. But strangely enough, you could probably buy one of these for half the price of a Rotel 230. So he's got a transmit problem with it. I think we'll get this opened up for a start. There you go, bigger speaker, transmit issue. See if there's anything straight away that I can spot. Can't even see cracked cores. Can't see any dodgy capacitors. I'm not sure what that extra capacitor does, but it looks factory. So high-low power is annoyingly at the bottom, at the back. Is it 13th today? Sounds, yeah, it is. Unlucky for some. 13 Oct 2023. Fidelity 2000. One oh nine oh 576. I'll probably make an excuse up to deliver these all back to him personally. I'll have to think of an excuse. Okay, well I'm going to put our extension speaker in. I'm going to plug it into PA, connect the test equipment. No loose sockets. Talking about personal collection, we've got a Fidelity 1000 coming in tomorrow, and the gentleman's bringing it personally because he doesn't trust the post. So there you go. Hope I can fix it. I've had a big journey. Right, power on 13.8 volts. PA. Testing 1 2, testing 1 2. Fine. I'm not sure why I haven't got receive. Got the mic plugged in. Is that because I haven't got anything plugged into extension speaker? Yes, Mr. 21, that's right. Volume control noisy. We're looking for the Fire Stick advert. Never lick a stick for the about 1981. Ba-dum-da-dum. Transmit. Pick picture in picture on. So at the moment we're drawing 244 milliamps. Going to transmit draws 280 milliamps and does little else. Go to low power. That was just in case. Check the VCO. Which need to do anyway. Channel 40. Need a crocodile clip between there and earth, and we're looking for 4 volts. End of resistor 4, and on transmit we're looking for 4 volts. So we've got both those. That's perfect. Now change channel to channel 1. Should have between 1.8 and 2.3, 1.8 and 2.1. So that's the VCO is spot on. Good. Right, put monitor receiver on. Select channel 20. Testing 1 2, testing 1 2 1 2. So it's transmitting a few feet. So the VCO is generating a suitable voltage. Let's see if we can tune it up. In fact, we'll do it with the monitor receiver on. Tune up for least noise whilst looking at the ammeter. Got a broken one there. Feel that's a better peak. About right. The broken one. I think we'll take this out and put it in the other way round. Unless it's already been turned around, that one. What we got? Interesting. How can that not fit? It's just gone right to the bottom, yeah. I've just taken this out of the same position. That's absolutely bonkers. You know what? I wonder if somebody's changed that and put a wrong one in. I remember having this with a team set once, and somebody put a choke in instead of a transformer. Trying to find it on this side. It's that one, isn't it? No, it's not that one. It's that one. Right, it's got to come out. Right, I'll pause the video while I do that. Okay, so I've put a new coil in. So, let's see what happens now. Hey, there she blows. Now that looks to me at the wrong end. Let's just move it to the other end. So it's on the wrong, I've got it going up instead of down. Right, well, we'll go through the transmitter. So we're doing more than 3 watts. It's actually doing 4.1, so just get that peaked. So that's peak at 4.6. We'll just go through these. That one. That one. I don't get it. So I've taken this out, and because it had a broken core, I took it out and took one out from this set, this coil, but it fell down it. So it told me it was actually the wrong transformer. It's still a Mitsumi 10C006. Can't see now, can I? Oh well. That's fixed it anyway. So we'll go over to the... Just a daft observation like that, it brings us up to the fault. Not sure where the tools are, we'll use these. Yes, these come from an amusement machine spares, video games from the United States. So by the time you've imported them, they've cost a lot of money, like 18 quid a pack. So I don't lose them. Well, that doesn't want to fit. That one wants to fit. So I need to max these. So 4.6 watts. That doesn't want to move. That's already at peak. I think this one, I think someone has turned this up and then they've maxed it to try and get the maximum out of the radio instead of maxing it and then dropping it back as the tuning procedure. And I think some of these coils have actually melted. So what I'm going to try and do is lose all the tools. I may have to find an Allen key to shift it, because otherwise I'm going to end up destroying the plastic tools. That's not an Allen key to do it when in transmit, that would not work out. And bit delicate because they're so easy to break. Do we have any Allen keys on here? Is the big question. Borrow something off Mr. Chippy's bench. Okay, so we've got a little Allen key, which hopefully, I'd hate to have to find some more of these. I have to jam something down there, some insulation. It's just too tight. I think they've had it at a power level that started to melt the former. Right. So I'm glad we did that. It's going on and off this set as well. There's a dry joint under there. Yep, there is. There's a wicked dry joint on the very coil we're working on. See if we can zoom in on that. Let's see where we are. So this one, I'm going to wiggle it from behind. Because it's been so hot that it's actually unsoldered itself. Good. Now back to the question in hand, trying to tune it. Backwards and forwards. Put the camera back to normal. Okay, so we're at 4.8 watts. .8. So that's our peak. So now we need to take this yellow one clockwise for 4.4 watts. So we'll need our sliver of stuff back. That's the Allen key on the floor. It'd be nice if I could tune it with an Allen key, but of course you can't because it's metal. Oh yes, we've seen the golden screwdriver experts try that. Clockwise for 4.4 watts. There's 4.4. And then anti-clockwise on the green one for 3.8, says the service manual. But because you're allowed 4, we'll tune it to 4. There we go. I've said it many times before, it's because they have to get sets through customs. They're all set low. Right, so we've got 4 watts on channel 20. What we got on channel 40, we've got 4.02 or something like that. And on channel 1, we've got, well, 3.98 or something. So that's pretty well balanced. Right, back to channel 20. Power consumption, I don't know what it was before because it wasn't working. It's very efficient, 1.157 amps. And low power is doing 90 milliamp, 90 milliwatts. We'll just bring that up. I think that wants a bit of a spray. Sometimes they need changing. That's 400 milliwatts. Back to normal power. There we go. Good. Deviation. Wow, 1.8 on this test set, but we don't believe this one, so we'll go to the one behind me. Wow, 1.8 on that one, so it wasn't lying today. So I want the deviation first preset in the vertical position, and then we'll adjust it on that one. Needs to come up a little bit. Just check mic gains at full. Yeah, it is. Wow. The bestest trimming tool on the floor. Switch your test set off. Plug us back in. Get on floor. Let's see what the deviation is on the Marconi test set. Wow, he's spot on. It's not lying today. It smells of cat, this radio. Right, we'll put the expensive trimming tool back. And let's see what the RF power meter says. We'll key it up. Boing, 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 boing. It now says 4. Frequency. Pretty close. I could leave it at that, but we'll just get it spot on. Right, now we'll have a look at the receiver. He's probably done this. Signal generator to 2779125. That's one. Let's see what we've got without touching it. So at the moment we've got a very okay 0.43. It's supposed to be better than 0.7, and it certainly is. 0.35. Let's put that to the attenuator. And for 100, sorry, for 21. Squelch. It's 30. Threshold. Not 0.3. S meter. That's 100 microvolts on the signal generator. And we've got 7. So what does it need? Needs 10 millivolts. So that's quite a bit out. Ye lazy. Right. Let's see if we can improve the receiver. We'll go over to the oscilloscope first. And see if the detector's set right. Yeah, that was spot on. It's probably gone through this, as I say. Go to the sine nav meter. Turn the squelch off. So we want about 4 dB. Keep it there so the receiver isn't saturated. No, he's not been through the receiver. Back to 4 dB-ish. No change. No change. The biggest signal on for this. Just the one which was out. That'll give us a new figure. So there's our 12 dB. And it's now 0.23. .2 and for 1 0.6. Squelch we're probably going to have to alter. Squelch to full. I've got 30 microvolts on the attenuator, so I will adjust the squelch preset. While we've got 100 microvolts, no we haven't, that's 100 microvolts. While we've got 100 microvolts on, we'll do the S meter. There's 100 microvolts on the S meter. So, back to what we were doing. Squelch is now set, 100 microvolts for tight squelch, and for threshold now 0.56. There we go. So I'm going to take a break and what we'll do is come back and clean those controls. And that is a nice working set, a very nice working set. Right, we'll draw this to a conclusion, sprayed the volume control, and all we need to do is put it just now on its internal speaker. We now take it off the test equipment and put it onto the Antron 99 roof aerial. One Anna, Roger. There we go. So we're doing on the air test to that. So just to recap, wrong coil in the transmitter and dry joint in the transmitter on that coil that I had to get the core out of and get it to move because it's been tweaked up and the power it's generated has melted the core. So there we go, we're done. Thanks for watching Fidelity 2000. I don't know what we've got tomorrow. I know we've got a customer's yeah, we've got a Midland 2001 coming from an end user. Thanks for watching.